let's go ahead and look at this. Guys, look at this warm up real quick before we jump to homework. Okay? This was basically the first part, writing the intervals of increasing, decreasing, and describing its behavior, was essentially what your OPQ was on that you had to take last week, and there were several of us that still need to do that. And remember, you can retake those as many times as you need to. But if we look at this particular polynomial, and I've graphed it for you ahead of time, let's decide right now what the degree of the polynomial is. What degree does it have? Maybe we're not sure. Do we know that it's an even or an odd degree? We know it's an odd degree polynomial. No, it's not an odd degree. It's an even degree. Why is it even? Because the ends are both down. Remember that the end behavior talks about the degree of the polynomial. If the degree is even, 2, 4, 6, 8, 10, remember that means the highest power, that the ends are either both up or both down, right? Okay. Since they're both down, I know two things. I know that it's an even degree polynomial, and I know that the leading coefficient is what? Negative. So I know that ahead of time. All right, so let's start by talking about the intervals of increasing and decreasing and behavior. So, and behavior. As x goes to positive infinity, what does y do? As x goes to the right, what does y do? Goes to negative infinity. And as x goes to the left, or as we're looking at the graph to the left, or as x goes to negative infinity, what does y do? It also goes to negative infinity. So that would be how we would describe the end behavior. Good. Intervals of increasing and decreasing. I'm just going to highlight the places on the graph where it's increasing. And I'm going to highlight in a different color the places on the graph where it's decreasing. Notice I have 2 for each. Is that okay? Yeah. Sure. So let's start with increasing. It's going to be increasing from negative infinity to what point? Well, I've got to figure out what that point is. Wouldn't you agree? It looks like it just kisses that axis and goes back down. So that is the point negative 4, 0. Okay? So negative 4, 0, well, that would be from negative infinity to negative 4. Okay? And we're also going to look at a different interval. The other place is from, well, I've got to figure out what that point is. And I didn't tell you that. And so if you had an equation, could you figure out these local max and local mins? Probably. What if I just estimate them and give you some numbers? So let's say negative 2, negative 2, negative 5. We'll put that as that point. And then this point would be the point 1, 2, 1, 2, 3, 4. So 2, 4. I'm just going to estimate, okay? Because if you had a calculator, you would find it exactly with the equation, wouldn't you? So increasing from negative 4, I'm sorry, from negative infinity to negative 4, and then it starts again where? Where does the yellow start again? At negative 2 to positive 2. Remember, we only use our x coordinates for this, don't we? We don't look at the y coordinates at all. For decreasing, we're going to be looking at the blue highlighted segments. It's decreasing from negative 4 to negative 2, and from 2 off to the right, or 2 to positive infinity. I know it's going down in the bottom sheet, but we're looking at the x's. We're looking at off to the right. Right means positive infinity. So those are our intervals of increasing and decreasing. So that's kind of what you were asked to do on the quiz. Graph it and write your intervals and end behavior. Okay, remember, intervals of increasing and decreasing, we're only looking at x values. Hopefully, during flex tomorrow, if you would like a chance to retake your OPQ, you can do that. And if we have time towards the end of class today, you can retake it then too. I'm not sure if we'll have time in class today or not, but definitely during flex tomorrow, or supplemental period tomorrow. Okay? Now, what we talked about last class was writing the equation. What do we need to write the equation? Do you remember what we need to look at? We're not looking at the max and mins anymore. What are we looking at? The zeros. Okay? So we have 3 zeros. Do you agree? 1, 2, 3. But one of those zeros you know which one it is? We'll get to it. Let's write what the zeros are. What are the zeros? Negative 4 is a root. It's a 0. So if negative 4 is the 0, what's the factor? X plus 4. Right? Negative 4 is the root of the 0. X plus 4 is the factor. Give me another 0, and we'll write it in factor form. X minus 3. I agree with that. X minus 3, because 3 is also a 0. Now, what about this one in the middle? It's just a 0. It's just a root. It's just 0 is the answer. Some people like to write it this way. That's okay with me. There's nothing wrong with that. But oftentimes we don't do that, and we just put a plain old X in the front. Okay? That is okay too. I would accept it either way. Now, we're not finished because I told you, 1, we have a multiplicity, and 2, what does our leading coefficient need to be? Negative. So we know we need to put a negative in front. Would you agree with that? Because the end behavior is down. And we have a multiplicity. What I mean by that is we have two different things. We have multiplicity of 2 and multiplicity of 3. When I have a multiplicity of 3, I'm just going to make something up. X plus 1 to the 3rd. Doesn't that mean if it's to the 3rd, I have like a little flattening out place in the graph? Remember that? What if it's squared? What does the graph look like? It's when it does what? Kisses the axis. So do I have any kissing here? I'm going back down. Don't I have a little place where it does that? Right here at negative 4. So that means that this factor has to be squared. It has a multiplicity of 2 because it kisses the axis there and goes back down. Now, let's double check that I have an even degree polynomial. Because don't I need to be even? Because the end behavior is both down. So what is the degree of this polynomial? If I multiplied all that out, how many x's would I have? What would be the highest power of x? Would it be 2? Would it be 1? Would it be 3, 4, 5? What would it be? How many x's do you see? Let's count them. We have 1x. I have a double root, and then I have another one. So what's my degree in this case? 4. So if I was going to multiply all of this out and put it in what we call standard form, wouldn't I have an x to the 4th? Which is an even number, isn't it? So I have an even degree. I have my correct end behavior, so I have a negative in front. That is an equation that matches this. I'm done. Okay? Let's look at the answers to the homework. For those of you that did do your homework, here are the answers. I realize they're a little small. Let me see if I can make them a little bit bigger here. Remember, you only had to do the evens. So look for the evens only here. I'll let you check your homework while I put attendance in, okay? All right. I happen to think on these questions, it said on 24, it said write it in standard form. I'm not a huge fan of that right now. Right now, writing it in factor form would have been okay. But let me tell you what the answer would have been on 24 in factor form, okay? So in question 24, it says here to write it with the given zeros. So in question 24, the given zeros were 0, 4, and negative 1/2, right? Now, did I give you some other information as well? Did I tell you that, like, f of 0 equals and give you another number? I didn't? Sure? All right. I think I should have, but I didn't. Okay, fine. So if those were the zeros, honestly, if you would say x minus 4 is a factor because of that one, you would say, the negative 1/2. How many of you did this? Anybody do that? That is okay, but that's probably a better way to do it, okay? And then this one would have just been an X out in front, okay? Now, we normally don't write things in factor form with fractions, okay? So with the negative 1/2, we actually would write it this way instead. Now, how in the world did I get that? So let me show you. So this would have been probably what I would have liked to see, okay, is this answer here. Let me show you how I got 2x plus 1. If I have negative 1/2 as a 0, okay? Do you agree with that? Negative 1/2. Actually, wouldn't it be x plus 1/2 equals 0? 2 here, 2x plus 1 equals 0. Is that okay with you? Notice we get the same answer. If I subtract 1, divide by 2, don't I still get negative 1/2? So whenever you have a fraction like this, I tend to write it in this form like this. Okay, you'll see that written that way better. Because the leading coefficient is, this is your coefficient of x, and the not. Like, so I would have been okay if you left it like that. Okay? Now, when they say standard form, they just mean multiply it all out. And we'll get to that eventually. But we're gonna stick with factors today. Good question. Thank you for bringing that up. Anything else on the homework that you guys wanted to go over? Anything else at all? How about the graphs? Did the graphs go okay for you? Yes, no, maybe so? No, I'll be quiet. Because some of y'all didn't do it. 30. I'd be glad to. Let's look at 30. All right, so question 30. 30 says, again, find the zeros and state the multiplicity. So here we have y equals x minus 2 squared, quantity squared, and x minus 1. So what they mean is, first of all, what's the degree of that polynomial? What's the degree? It's 3. We have 2, the double root here, and then we have this root. Would you agree? 3. The degree of 3. All right. So what they mean is, if x minus 2 is a factor, then 2 is a root. If x minus 1 is a factor, 1 is a root. So those are the 2 roots, but this one has a multiplicity of 2, or we can say it's a double root because of the split. That's all I mean. That's all you have to say. Well, that's nice, Miss Macker, but that's great too. Did you make me go through it all? Okay, 30. All right, 36. This one we had a factor. This one, this one's not in factored form. And this is awesome because this is exactly what we're going to be doing today, is factoring polynomials to get it to look like this so we can figure out what the zeros are. So this is what we call standard form. We have to put it in factored form. Is this the right one now? Okay. So what we need to do is factor this. And there are multiple ways to do that. And we're going to talk about, we know some of the methods of factoring, but we're going to go over a couple more today. First thing we always look for, always, when we're factoring is a what? Begins with G. GCF. Is there one here? 3x is a GCF. So I'm going to take a 3x out. What am I left with? Is 3x to the third? Is it quantity 3x? I don't know. 3x is not GCF. If it looked like this, I would agree. What's the only thing being cubed in the first part? Is just the x alone. So this, the only GCF is 3. Actually, there is a 3x. Let's get 3x out. I'm a liar. Hang on, let me just finish with it. So I have x to the third minus x. Would you agree with that? You can still take an x out. So I agree. I'm sorry. So we have x squared minus 1. Do you agree with that part? Yeah. Okay. All right. Now, can I factor what's left? Who remembers what that is? A difference of perfect squares? What's the square root of 1? 1. So we're going to remember this x plus 1, x minus 1. Guys, we have all these different factoring things. So these are the factors. So how do I find the zeros? So the zeros are going to be negative 1, positive 1, and 3. When I set this factor equal to 0 and I divide by 3, what's 0 divided by 3? 0. So 0 is also a 0. A root. There are 3. Degree of 3. We expected there to be 3. That was a tough one due to factoring. But it's a perfect lead-in to what we're going to do today. Okay, we're going to be looking at factoring. How many of you still have the foldable that we started last class, like probably a month ago, when we started talking about factoring? If you happen to have it, get it out. We are going to add to it at the bottom. But I also have a little kind of handout for you that's going to summarize some of these factoring techniques. So what we're going to be working on today is actually all the different ways we can factor polynomials to get our zeros. So just like we had in this example, it's the perfect example to start with. When it's given to you in something called standard form like this, we're going to have to factor this polynomial in order to figure out. Because when it gets in the factor form, it's easy to see where the zeros are. We know we can look at the factor and we can figure out the zero. But when it's in standard form, it's not so easy. So I'd like us to practice today factoring some more. And the factoring methods are going to be a little bit more complicated than what you're used to seeing. So let's go ahead and look at some of the, let's refresh our memory just for a minute. You don't have to write this part down. But let's just see what we remember. Which one of these top polynomials is not cubic? Which one of these three? Are they all cubic? Is the first one cubic? Because you have x times x. That is cubic. How about the second one? Cubic? Yes. Third one? No. This is not cubic. How about the last one? Yes. Okay? So this first one already happens to be in factored form, and then the other two we're going to get to factored form eventually. How about now here? Let's make sure that these are cubic. Now, what about this first one? It is not cubic because I have a cubic on the top. Guess what? I have a x on the bottom. This is actually called a rational function. We don't even know what that is yet. We don't have it divided by things. None of these divide by things. So what's the only one that we know that is cubic? This one right here. Okay? Except, can't I divide x out from both of these cases? Doesn't this reduce to x cubed plus 16? It still happens, so it looks like it might be cubic, but it's not a polynomial because that x actually has a hole in the graph, believe it or not. So we're not going to count it. Anything that divides 5, we're not going to count. That's our only cubic expression. All right? Coefficient, what does that mean? What does coefficient mean? The number in front. So the coefficient of the cubic term. So look at this one. What's the cubic term? The coefficient would be 2. Perfect. How about this one? Okay. The coefficient would be? All right. So we know what we're looking for is that the highest, the cubic term is the power of 3. Good. Now, we know how we're going to get to the solving part in a minute. All we're going to do today is the factoring part. So I have this sheet given to each of you. It's a little half sheet. I realize it's hard to see. So I want to make sure that you're filling out this sheet as we go along. Okay? Everybody has their own. So the first one we already know is your GCF. Okay, so we've already done that. That should have been in our foldable, should have been the very first thing that we did, GCF. So if we look at this example, is there a GCF that I can take out of all 3 of those? Look at your example that you have on your half sheet. Is there anything I can take out? What's the largest number that I can take out of everything? 4. Now, what's the highest power of x that I can take out of everything? Each of them have at least how many x's? 3. So I'm going to put 4x to the third is my GCF on the outside. I agree with that. Do you see how we're left with 3x to the third with the first term? Because 4 times 3 is 12. And x to the third times x to the third, remember you add your exponent, so 3 plus 3 is 6. Okay? Let's take out a 4x to the third out of the second term. 4 times what is 8? So now I'm going to have a 2 here. What is the power of x that I have? 1. So I took 3 of them out. I have 1 left. What's my last term going to be? Do I have any x's at all? I took all 3 of them out. So what I'm left with is just what is 4 times what is negative 48? Negative 12. So that is going to be the GCF. Now, we can at times look, don't do this, don't highlight this, but we should always look to see possible to factor out what's left. Now, because I have an x to the third here, probably not factorable. Okay? But you always should check that. If it's quadratic, maybe it is. All right. Let's look at the next section on your half sheet, quadratic trinomials. So I want you to go ahead and try number 7. I've started it for you. I have a 2x here. I want you to tell me what goes in the blanks there. If you want to try to factor by grouping first, that's okay. But I want you to look at number 7. Try to factor that one on your own. Tell me what the two numbers go in the blanks. All right, so let's go ahead and look at number 7. Now, some of you can probably figure out the answer, but so let's look at this the way that we've usually factored it. So 2x squared plus 11x plus 15. When we talked about factoring this a while ago, back in the day, remember we made a little x, and we said two numbers have to multiply to be what? 2 times 15. They multiply to be 30, and they have to add to be 11. Do we have those two numbers? 5 and 6. Wouldn't you agree? So what do we do with the middle term? We rewrite your middle term. So we have 2x squared plus 5x plus 6x plus 15. Remember, we're just rewriting your middle term using those two numbers. Remember this from before? This is review stuff now. All right? So at that point, we're going to group. We're going to look at our first two and our last two terms. What GCF can I take out of the first two? Just the what? X. Then I'm left with 2x plus 5. I have to have a 2x plus 5 over here, wouldn't you agree? And then what can I take out of the last two terms to get 2x plus 5? A 3. Positive 3. So what are my two factors? 2x plus 5 and x plus 3. Is that what you guys got before? So that's what we're going to plug in. 2x plus 5 and x plus 3. Has to be in that order, right, Brendan? Okay. Perfect square trinomials, I didn't really focus too much on that. It's not really that important, except for we know that when we have a 14x here, that is x minus 7 times x minus 7, and we should write that as the one quantity squared. That's all. Okay, so I didn't really kind of emphasize perfect square trinomials, but if you had the same factor written twice, we can just write it as that factor squared. Remember that from before? All right, difference of squares. We talked about that just a second ago. X minus 1, x plus 1. Wasn't that one of the ones we did on question 30 for homework? This one I don't like their example, because 11 is not a perfect square, is it? So I don't like that. Can we change that, do you mind? Can we change this one to be 121? Because if you change that, isn't 121 a perfect square? Let's change that square root of 11 too. Okay? So, what is the square root of 16? 4. So I know I'm going to have a 4x in the numerator. 4x is the first term in both of them. The pattern is one of the signs is a plus and one of the signs is a minus. And then what's the square root of 121? 11. So I'm going to put 11 here and 11 here. So I have 4x plus 11 and 4x minus 11. So you really, when you're talking about a difference of squares, we really want to look at, do both of my numbers, are they both perfect squares? That's all. Okay? All of these things we've done so far are foldable, haven't we? Up to this point. It's the grouping we've even done. Okay? It's the last one that's our new form of factoring that we're going to add. Okay? So, let's look at factoring by grouping. What is a key that tells me I should try to group? How many terms must I have in my polynomial? I have to have 4. 1, 2, 3, 4. Because I have 4 terms, I know I can group. So what we want to do is we want to look at the first two and the last two. In the first two, what's the GCF? X squared. I'm left, when I take out x squared out of both of them, I'm left with x minus 3. Well, I have x minus 3, so what goes there? 1. So my two factors are x squared plus 1 and x minus 3. You're just looking at factoring by grouping. You're looking at your first two and your last two. You have 4-term polynomial. Again, all of this is review up to this point. This last one is what we need to add to our foldable. So we're going to start with the sum of two cubes. So if you have your foldable, if you would please go ahead and look at, I think you have three blanks at the bottom, is that correct? You should have 3 blanks. Let's go to the next one that's available and call it the sum of two cubes. So we're going to write the sum of cubes, and we're going to write this formula. Okay? Can you see that? Well, you have the formula on your own paper too, right? So we're going to do the sum of cubes on one of them, and we're going to do the difference of cubes on the other. Okay? So sum of cubes and difference of cubes. You're going to use 2 different sheets to do it. Please write the formula for each. So let's do the example here, 8x to the third plus 27 on our sum of two cubes foldable. So you can put this 8x cubed plus 27 as your example. The thing that we have to recognize is, first of all, what is the pattern here? Well, there's 2 terms. It's a binomial, just like with the difference of squares. Didn't you start off with a binomial here too? So we have a binomial situation. But this time we're not looking for differences. We're not looking for perfect squares. We're looking for perfect cubes. So your first term should have an x to the third. Okay? Should. Now how do I know if 8 is a perfect cube? Well, what times itself 3 times is 8? It's actually 2. If you're not sure, like if the numbers get big and you're not sure, you can always check it using your calculator. You can always go ahead. You can check on your calculator. If you go to the math key on your calculator, go ahead and find it for me. And you go down to the cube roots, which is option 4. Right, and I want you to try it on your calculator, please. Math, option 4. And if I type in the cube root of 8, tell me what you get when you type it in. You should get to be a perfect cube. Check 27 as well. Is 27 a perfect cube? Type it into your calculator. It should be. Math, option 4. Now I'm going to do the cube root of 27 as well. So they're both perfect cubes. So here's what we're going to do. We're going to write it in this formula, this a cubed b cubed formula. So do you agree that 2x to the third is the same thing as 8x cubed? So our a in our formula is 2x. Our b in our formula is simply 3. So a is 2x and b is 3. I'm going to use this pattern or this formula to fill in what my numbers are. So it says the first factor is simply a plus b. So my first factor is 2x plus 3. I'm just looking at my pattern. That's all I'm doing. My second one is going to be a squared. Well, what was a again? 2x squared. So please do not just write 2x squared. It's all 2x squared. The quantity 2x. Notice my pattern. I have a minus sign. Then I have a times b. What is 2x times 3? What's 2 times 3? So I have 6x. My I'm using my formula again, plus b squared plus 3 squared. Now, I need to simplify it a little bit. I have 2x plus 3 as my first factor. Not this factor. It checks, doesn't it? My second factor, how did I get 2x quantity squared and then got 4x squared? Why? Where did this come from? Isn't 2 squared 4? So you have to remember to square the big number in front too, that's all. Okay? So 4x squared minus 6x plus, what's 3 squared? 9. So that is the correct factoring. That's a sum of cubes. Okay? Now, in your difference of cubes, I still want you to write that formula, but let's pick a different set of numbers to put in here. A difference of cubes. Put it into our foldable here. Let's pick some numbers. I'm going to pick, so in our difference of cubes, you can put this in your difference of cubes part of your foldable if you want. The difference of cubes, let's try this one as our example. Let's try x, let's try 125 x to the third minus 8. Doesn't fit the pattern of a difference of cubes. Is it a binomial? Claire, I need you to put your phone away. On your desk is not away here. Claire, on your desk is not right here. Thank you. Is it a binomial? Yes. I don't care about the sign in the middle. It could be a plus or a minus. When I did a difference of squares before, it had to be a minus. But we're talking about cubes, it doesn't matter. Are they both cube roots? Are they both perfect cubes? Well, I know 8 is 125. What's the cube root of 125? So is it a perfect cube? Yes. So let's write it in using our notation for our formula here. I know that 5x to the third, remember all of 5x, minus 2 cubed. So I know what my A and I know what my B is. A and B. So what I need to do is I need to plug it into my formula now. So we have 2 factors. The first one's a short little cube factor. It's just A minus B. So it's going to be 5x minus 2. Done. The second factor is a little bit longer. Look at your formula. It says a squared. So what do I write? You better not write just this. What's wrong with that? I need a parentheses. Or you can just say 25x squared. If you don't want to, you can square the 5 already if you want to. You want to just square both of them right away? Is that okay? It's fine with me. Make sure you square the first number too, if there is one. Then I have a plus. Then it's A times B. What's 5x times 2? 10x. And then I have a plus. And then I have b squared. Well, b is 2, so what's 2 squared? 4. So that is the full factorization of the difference, or in this case, the difference of cubes. Okay, so you have all these different ways to factor now. Okay, we're actually done. That's it, believe it or not, in terms of factoring. So what I have for us is some practice with this, not just the sum and difference of cubes, but definitely some practice with it. But every person's going to get a different set of problems. You have 12 problems that you're going to need to factor. So let me hand these out, and everyone's going to get a different set here. So you're not going to be able to kind of look at everything and decide. These are mixed together with grouping. There are all of these different ways of factoring together. So what you'll need to do is you'll need to look at this, either your foldable, or you can look at this little half sheet that we put together and look at the various different ways that we can factor. Okay? So that's what I'm looking for. You should right away, if you see something with 4 terms in it, now I'm looking at version 4. Okay, if you have 4 at the top. Look at questions 5 and 6. Don't they have 4 terms in it? So what immediately is the way to factor those? Grouping. So identify those. Identify on your own paper. Find any polynomial that has 4 terms. You know you have to use grouping there. Don't forget to always check for a GCF as well. If you have a binomial with an x cubed in it, and there are several of those here, this is our new way of factoring, the sum and difference of cubes. So I'm looking at version 3, if you have a 3 at the top. Look at question 1, 2, 3, and 4. Actually, I think on all of that one, questions 1, 2, 3, and 4. They're all different questions, but aren't questions 1, 2, 3, and 4 all sum of or difference of cubes? So make sure you realize questions 1 through 4 is this new way. All right, so that's our first way of factoring. And then we have grouping, and then we have GCF and difference of squares and things like that. Okay, so all of them mixed together then. So I want you to go ahead and be working on this.